Hello, in this video we're looking at MEI FP2, the January 2011 paper, question 1a, which is on polar coordinates. This part question is quite separate from the other part of the question, which is on series and can be found reviewed in the FMSP Revision video on calculus, polar coordinates and series. Read through the whole of this part question first. We start with a polar equation and note the range of values for theta, which is possibly not what you usually see. The first thing we're asked to do is to show that the Cartesian equation of the curve is this one given. So we need to make sure we've got enough working there. Then it says hence or otherwise sketch the curve. We've got a choice, but usually the hence method will be simpler and quicker than trying to do it by some other method. And then for part 2 we've got to do an integration, finding the area of the region bounded by the curve and the lines theta equals 0 and theta equals a half pi. Note that you're asked to give your answer in terms of pi, so we're looking for an exact answer and not a decimal. So starting this question, we've got to convert from polar to Cartesian. So we'll need to use these three relationships: x is equal to r cos theta, y is equal to r sin theta, and x squared plus y squared is equal to r squared. Those are true for any Cartesian coordinates x and y and polar coordinates r theta. So we'll start with the given polar equation. R is equal to 2 cos theta plus sine theta. And I want an r squared. I'm not going to square both sides, I'm going to multiply both sides by r because I need r on the other side as well. Now I can substitute in my relationships. R squared we know is x squared plus y squared. 2r cos theta is 2x and 2r sin theta is 2y. So there we are already at the Cartesian equation given. Now I've got to make a sketch, and I can see from this Cartesian equation that it is the equation of a circle, so I'll just continue with my working to get that into a form where I can read off the centre and the radius. So x squared minus 2x plus y squared minus 2y equals 0. Completing the squares, x minus 1 all squared minus 1 plus y minus 1 all squared minus 1. And then I get x minus 1 all squared plus y minus 1 all squared is equal to 2, which is a circle with centre 1, 1 and radius root 2. Now if its centre is 1, 1 and it's got a radius of root 2, that means it's going to go through the origin. So it will look like this, and you're strongly recommended to use compasses in this exam to draw your circles. It does make it much easier to do a convincing diagram. So it goes through the origin. The centre is 1, 1, and the distance from the origin to the centre is root 2, and similarly it's going to cut the axes at 2 on both axes. Then we've got to do an integration, remembering that we've got to leave our answer in terms of pi. So our standard formula for area is a half r squared d theta, and our limits are going to be theta equals 0 and theta equals pi over 2. So we'll substitute in our formula for r. So that's a half times 2 squared cos theta plus sine theta squared d theta. So tidying that up, I've got a half times 4, which is 2. Take that out the front. Multiply out the brackets. Cos squared theta plus 2 sine theta cos theta plus sine squared theta. And then use identities to tidy that up a little further. 2 sine theta cos theta is the same as sine 2 theta, and cos squared theta plus sine squared theta equals 1. So this is now quite a straightforward integration. Integrate sine 2 theta and I get cos 2 theta, broadly speaking. Check by differentiating, I'm going to need a minus sign and a half in front of there to make sure that when I differentiate that I get back to sine 2 theta. And then integrating 1, I get theta. Then substituting in the limits, I get cos of pi is minus 1, so a half times minus 1 is plus a half. Cos of 0 is, and then plus pi over 2. And then take away, cos of 0 is 1 times minus a half, that's minus a half, plus 0. So that's 2 lots of a half plus a half is 1 plus pi over 2, which gives me as a final answer 2 plus pi. Okay, let's see how the mark scheme works for this question. For part 1, there is a method mark for using one of these relationships, which I've done here. There's then an accuracy mark for a complete and convincing argument. There's then a method mark for recognising that this is a circle and using appropriate algebra to get to something in this form. And then for actually drawing the graph, we've got 1 mark for a circle with a centre in the first quadrant, and another mark for the correct centre indicated and the radius marked, or showing clearly that it passes through the origin. For part 2, there's a method mark for taking the standard form and substituting in our formula for R. There's a method mark for tidying it up. There's an accuracy mark for using the identity cos squared theta plus sine squared theta and getting sine 2 theta. There are then 2 accuracy marks for getting the correct integration with the correct limits, and 1 mark if there is 1 error in that. A method mark for substituting in the limits, and that's dependent on the previous method marks, and then a final accuracy mark for getting the correct answer. If you want to find videos on other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.